Okay, so we're gonna start the 2.4 arc length of a curve and surface area in this section. So arc length looks like this, right? So when we talk about circle, we talk about the arc length in pre-calculus. Now, we want to know about the arc length, the length of arc, right? So let's say that from A to B. Okay, now we want to make the partition from A, which is x naught, and then there is x of 1, x of 2, x of 3, and x of 4, and so on, and keep going down, and then x of n, which is just indexed, all right? Okay, from calculus, we have a distance formula, just in general, right? So distance formula, which is the difference in x squared plus the difference in y, right? So index, right? y2 minus y sub 1 squared. Okay, now we have a partition we make in this case. So a equal to x naught less than x sub 1 less than, oops, x sub 2. And until x sub n, which is b, okay, a and b. Now let delta x sub I, which is equal to x sub I minus x sub I minus 1 index, and delta y sub I, which is y sub I minus y sub I minus 1. Okay, so today we are using index, all right? So sub I minus 1, okay? Now, I want to make the arc length like a L. How about that? Because the book does not have a notation. All right, so this one, we want to say that square root of difference x and difference in y, okay? All right, so not only one, so we're gonna use a summation. The index come from I, it start 1 to n. All right, now we know that this one is delta x sub I. That's how we get from, right? So we have delta x sub I squared plus delta y sub I squared, all right? Now, I want to multiply delta x sub I squared, which is 1. So look how I multiply. So multiply in this case. Delta x sub I squared plus delta y sub I, and multiply by 1 in this case, delta x sub I. And since we have a square there, I want to multiply by 1, which is delta x sub I squared. So, multiply by 1. Delta x sub I over delta x sub I square. Square there. Square. How about that? Okay. All right. Now look that Look, we can factor out, look, they have a common factor, which is delta x sub I squared, right? So we're gonna factor out. So we factor out here, which is 1 in this case, plus factor out. So delta y sub I squared, factor out. Then we get, oh, I want to factor, why are we factor out that? Oh, there is not delta x sub I, right? Oops, so sorry. So delta, so delta x sub I, okay. All right, so let's save the step because I don't want to write down again. So factor out this, right? Then we have just delta x x sub I outside of the radical, right? So we will have delta x sub I quantity squared, and we will have, in this case, delta x sub I, all right? Okay, now we're done. We stop for now. Then I want to go over, I know you guys need to write down, recall. I'm gonna show you after this lecture, mean value theorem from Calculus 1. So we often denote a MVT, mean value theorem. So let me write down, if f continuous on the closed interval and differentiable on the open interval AB, then there exists C in between A and B such that, so we have formula which is f prime of C equal to f of B minus f of A all over B minus A, okay?
Could you scroll up, please, for a second? I just missed something, but okay. Okay, thank you. That's good.
All right, then look, this means we know what this one comes from. This is a slope, right? And then pre-calculus, we denoted this one is a slope of a secant line, right? So we had delta y over delta x, which is rise over run, which is the change in y, change in x. But change in y, we are using function notation, right? So this is slope of a secant line. So let me write down quickly. So we have that. We have 2 points we connect. Then this is the secant line. Yeah. So this is the point A, f of A. Then this point is B, f of B. Then there exists C is in between A and B. Then we have this point here. Okay. So this is f prime of C, which is slope of tangent line. So slope of secant line. All right. Then by MVT, we can conclude by MVT. There exists C is in x sub I minus 1 and x sub I such that we can have f sub x sub I minus f of x sub I minus 1 and equal to f prime of C x sub I minus x sub I minus 1. This is the same as pre-calculus, but then we are using the calculus 1, the slope of tangent line, right? So this one, like from the M, from the algebra course, right? M, then this becomes slope of second line, then slope of tangent line, right? Okay. Then we solve for f prime of C. So we will get f prime of C, which is divided by whole thing, right? So divided by this one. Okay. So we will divide by f of x sub I minus f of x I minus 1 over x sub I minus x sub I minus 1. Okay. Now, this is the same value with delta y sub I, right? Change in y variable, right? Same as just the function notation, y interval notation, right? So this will be, we change that. This is, we can say this notation of index and then delta y sub I and delta x sub I. Okay, now let me, okay, hold on 1 second. Let me bring this one from the last one. Can I copy? Please copy. Let me copy. Copy. Can I copy? Did not listen today. Come on. Come on. Let me copy. Yeah. Oh, got it. Oh, earlier. Oh, okay. Copy. Okay, good. So we have that. Okay, now we have this. Okay, then we can substitute. This will be f prime of C, right? Which is index sub I. So let us do this. I from 1 to n, 1 plus f prime of C sub I squared delta x sub I, right? Okay, now done. So we take the limit when n approach to positive infinity. We have a summation I from the 1 to n, and we have a square root 1 plus, we're gonna change this notation f prime of x in general, right? So general, we are using f prime of x. And then if we want to know about something, then we specific point A or C like that, right? So f prime of x, then square delta x y. All right, now this one come from the Riemann sum by Riemann sum. This one becomes the integral from A to B, and this one, oh, where are we going? this one becomes dx. We know that, right? And then we're gonna use the formula here. 1 plus f prime of x, then squared. Okay, so we derive the formula, right? Okay, this is for the x-axis, and also there is another one, y-axis. We have CD, and then since I introduced here, so I want to do that, g prime of y squared dy, okay? I don't have to rewrite it later on. Okay, so let us do this one. So do you need to copy down? Quick.
Yeah, I'm still writing down. Thanks.
Okay.
Not that quick.
Oh, then I'll show you later on. How about that? Is okay? Yeah. Since we have a time
Yeah,
limit,
okay.
yeah. I'm gonna show you from page 1 to the whole page later on, right? Okay, now we have number 1, f of x equal to 2x to the 3 over 2. And we want to find arc length. Interval 0 to 1. And then they say that round 3 decimal places. Okay, so we're gonna follow this formula. Something, why can you hear it? Oh my goodness. It's better write down faster. 1 plus f prime of x. All right, so look. We have f of x equal to 2x to the 3 over 2. What's the f prime of x?
It will be
Right.
2, 3 over
1/2? Yes? So
yes.
this is a 3, x to the 1/2, good. Now, I want to follow your book way because they make us square them so that we don't have to write down one more step, right? So
I
then-
have a question.
yes.
Do you prefer it to be in the form of 3x to the 1/2, or would you prefer it to be in like a square root fraction form?
Okay, so it depends on problem, but in this case, we have to write down this way so that we can simplify with the exponent. So let me show you right now, okay?
Okay,
So
thank you.
we are f prime of x, and then I want to use a square in this case, right? So that we don't carry over one more step. So then look, we have 3x to the 1/2 power to the squared, right? Now it's an exponent, so we multiply, right? That's what we need to write down 1/2. So we get what?
Is
Just
9x, very good.
Or yeah.
Okay.
Oh yeah.
Also this one,
1/4.
9x, right? Okay, very good. All right, then from 0 to 1, we have 1 plus 9x. We already squared them. What a nice, right? So the x. So we don't have to carry one more step, all right? Now, we have to integrate. How?
We just we could turn the radical into a half power, and then we could use u substitution.
Excellent. So we're gonna use U sub, maybe here.
U equals 1 plus 9x.
Very good. Then there's no. Okay, derivative one. We did derivative 1 plus 9x. Derivative with respect to x.
Is 9. So
9 dx. Very good.
So
So
one
we don't. Go ahead.
I was going to say 1 over 9 du equals dx. And then we can sub.
Very good. Yes. You guys studied a lot. All right. So we're gonna make that. So from 0 to 1, we have a 1 over 9 and square root of u. So we're gonna use the power. So we're gonna make a u to the 1/2. Then dx, which is du. Okay, now we can use the power 1 over 9. What do you have?
So u to the 3 over 2 power times 2 over 3.
Very good, from 1 to 0. Now, we cannot simplify, so 2 over 27, u was square root of 1 plus 9x, and we do evaluate from 0 to 1. So we have 2 over 27, and 1 plus 9 times 1 minus 1 plus 0, right? Okay, can you please calculate? Minus 1.
Is it 1.9 square root of 1.9x, or is it 1.9x in parentheses to the 3 over 2 power?
Oh, so sorry. Oh my God. So sorry about that.
That's okay.
Thank you for you catching up. Oh my God. Otherwise. Thank you so much. This is a 3 over 2. Okay, so this will be 10 square root and cube, right? And minus 1. Okay. So we don't need this one, but 10 square root. Can you please just using calculator make a decimal, because they say that 3 decimal places.
So I got 2.268.
Thank you very much. Okay.
Yeah, I got the same.
Okay, good job. Thank you. All right, so I will give you time to copy later on. So arc length, I have to do individual problem, whether we can make a integrate or not without using table or without using the calculator or app, right? So there is a couple of questions in the book, was not good. So I brought here some problem from other book. So f of x equal to ln cosine x, find the arc length in 0 to pi over 4. Okay. All right, so we're gonna find what's the f prime of x. And then Natural log. What do you get? Okay, whatever next line we bring down. Now remember?
1 divided by cosine x.
And what's the derivative? What's the derivative of cosine x? Channel.
Minus sine.
Yeah, I was gonna say it was
Minus sine x.
yeah.
Correct? Okay, good. All right. Then we have a negative sine x over cosine x. So how do we indicate?
Negative tangent x.
Yeah, it's a negative tangent x. All right, then we're gonna make a square them. F prime over x square will be negative 10x to the square, which is 10 square x, right? Okay, very good. So we're gonna use the arc length, which is from 0 to pi over 4 and square root of 1 plus f prime over x squared, which is 10 square x dx. Okay, what can you see? I know your classmate did a
So we could just move by down and we could simplify just like making 1 over 2.
Oh yeah, isn't 1 plus tan squared x equal to like secant squared x?
excellent. The secant square x. Okay.
And then the square root of that would just be secant.
Excellent. Does anyone remember integral of secant x dx? I showed you first day.
Oh, is it tan x? Or no?
This one, please
Oh,
look at the lecture note. Yes.
It's ln secant.
Excellent. ln secant x plus
tangent.
10x. Okay, now we're gonna evaluate from 0 to pi over 4. So, okay, for 3.1 lecture note. Or calculus 1, right? All right, so then ln secant pi over 4 plus 10 pi over 4 minus ln secant 0 plus 10 0. Okay, now secant pi over 4, we might think 1 over cosine pi over 4, right?
I was gonna say for secant pi over 4, it would be square root 2.
Square root 2. Yes, good. What about tangent pi over 2?
That would be 1.
Excellent. Minus ln secant 0.
0.
1 over cosine 0.
1.
1, right? Plus tangent 0.
Yellow.
Thank you. Okay. All right, then we get ln square root of 2 plus 1. ln 1, what do you get?
Yellow.
Okay, so minus 0, which is ln square root of 2 plus 1. Can you please calculate this one?
I got that. Oh, it would be 0.8813.
Very good. Excellent. Okay, this is the answer I have. Good job. You guys so smart. Okay, now let us do y interval. Okay, so let me give you time later. Please let me move on. Okay, so we have g of y equal to y minus 1, 3/2. Then find the arc length. And the interval from 1 to 5. Okay, so in this case, we're gonna use everything in terms of y. So we have g prime of y. How do we get that? Hmm? 3/2, y minus 1, 1/2 again, right? Okay, now we are using square them. So we have 3/2, y minus 1, 1/2, square them. So we squared, right? So this will be 9/4.
4 y
Here.
minus 1.
Okay, very good. All right. Now, let us using this R length, which is from CD, which is 1 to 5, and square root of 1 plus g prime of y squared, which is 9/4, y minus 1. We just squared already, right? dy. Okay. Now, in this case, we distribute. We do a little bit algebraic work. So 1 plus 9/4y minus 9/4. Combining like terms, so we have 4/4. Then what do you have?
9/4 y minus
Okay. So we have 1 to 5.
5/4.
Good. 9/4y minus, right?
5/4.
Good. Okay. Now we can take out the 4 as a 2 out of a square root. So can you see that? 1/2, then 1 to 5, and then 9y minus 5, right? So missing dy all the time. Now, we had the experience earlier, right? Those kind of problem. How do we integrate?
That u equal to 9y minus 5.
Excellent. So 9y minus 5. What's the derivative with respect to y in this
9
case?
yes dy.
Right. dy, good. Now, oh, looks similar, huh? So we have to do that.
u
Yeah,
over
1/9.
Yes. We had this one earlier too, right? So we get 1/2, 1/9. So we will have 1 to 5. Then there will be u to the 1/2 dy, right? Then what do you get? 1/18. Antiderivative.
u
2/3,
3/2.
3/2, sorry.
Then u was, looks similar. U was, now I don't make a mistake this time. So u 9y minus 5, 3/2 from 1 to 5. Now, can you please calculate 9y? So 9 times 5 minus 5. 3 over 2 minus 9 minus 5, 3 over 2. This will be 1 over 27, 40, 3 over 2 minus 4, 3 over 2. Approximately?
(9.07342).
Thank you. I got the same answer. Good. Good job. Oh my goodness. So fast. Very good. Okay. Excellent today. I mean, it was excellent last previous two. All right. So any question?
Would there
Okay,
be
let's
any?
go.
I was
Go
going
ahead.
to ask, would there be any time where we'd get problems like this and they would want it in a fraction form instead of decimal?
It can be, yes. It depends on problem, right? But then normally we are dealing with the lots of power, right?
Mm-hmm.
It depends on problem.
Okay.
I cannot guarantee, right? Yeah. All right, so let's move on surface area. Can you hear that? My neighbor though. Okay, surface area. So surface area. So basically we measure areas just outside, right? There is a surface area, surface, yeah. Not 2.4 is the total area of the outer layer of an object. They say the outer layer. Okay, so let me bring a screenshot here. Which one first? Okay, this one. So here, look, we have a curve, right? Then we make approximating this one with a line segment, right? And then the surface of a revolution, they do like this, x-axis, right? Can you see that? Revolving the line segment around the x-axis. All right, so let me make it bigger. Okay, so look, they say that when, don't move. When each line segment, I'm reading this one, when each line segment is revolved around the x-axis, in this case, x-axis, right? It produces a band, right? And these bands are actually a piece of cones. So look, piece of cone like this is called frustum, sorry about that, frustum of cone, okay? That's why I copy this one as well. Frustum, okay? All right, then I want to start one more screenshot. Where you go? Isn't it? Okay. This one. This is frustum, okay? Frustum. They denote like here is L. Here is the radius 1, R sub 1, radius 2, R sub 2. Okay. All right. Let me write down. Lateral, they call the lateral. Surface area. Let me denote the surface area like SA. Okay, surface area of frustum. This is strong? No, stum. Why I kept the R? I did not copy right. Stum, frustum. Let me copy here, stum. Okay, so this is a 2 pi R times L. Okay, looks like this is a circle, the circumference of a, that's correct, circumference of a circle, right? 2 pi R, then another length here, right? Okay, now this R, where R come from, equal to 1/2, and the first R radius plus second radius, right? So we add 2 radius divided by 2, which is average of radius, right? So average radius of first term. Okay, then let me write down. Let me bring the one more screenshot. I'm not good in the drawing, so. Oh, sorry. Go back. Sorry about that. Back and forth, back and forth. All right, so this one. Look. This first term like this, like make it upside down, look, as in here, right? Okay, there will be L. And this will be delta X. I'm talking about this one. And this will be delta F of X sub I, right? This changing the function, right? So changing function, which is the same as, we can say that delta Y sub I2, right? Okay. All right. Then we can say that changing L sub I, index I, right? Then we can say that square root of, same as we said earlier, the what is called the distance formula we are using, right? Delta Y sub I squared. Okay. Now, let me explain this one. Let R be average radius, because we said that earlier, R, right? Radius of frustum. Then by intermediate value theorem from the calculus, intermediate value theorem, we said IVT, then there is a point to exist say that R sub I, which is the same as the function 1 point there, okay? Oh, I want to make this sub I. Okay. All right. Complicate. So let me just show this one. That's it. We have 2 pi r L. Then it will be changed that so surface area, let's make a surface area like this, right? Surface area, which is 2 pi r lateral surface area first term, right? So 2 pi r times L, then we're gonna have 2 pi. Then we say that for the r, so we're gonna have f of this y, the specific point, then L was the distance of between the x and y, right? Then everything, the inside the square root, same as we did prove, like arc length, right? This part, and then this one will be 2 pi, and this will be take the summation of that. I have from 1 to n, and then later on, we take the limit and approach it to positive infinity. So this will be same as this is become same as 2 pi, the Riemann sum from A to B, right? And then this will be specific point, will be just a general function, f of x, and this will be 1 plus the R length, right? Okay, so surface area, look. Let me bring the formula, then we're done. So this one, copy. There too. This is the formula. We're gonna use that. Okay. The integration is not that hard. It's not like arc length. Okay. I think this is more easier than arc length. So let us do this one.
Could you scroll up for a second?
Sure. Since I'm moving this one. Okay. Okay.
Yeah, thank you.
All right. 2 more screens. So 1 more. Okay, please read. Okay, so we have the function square root of x. How it looks like, we know that. Now, over interval 1 and 4, rotating around x-axis, okay? So we're gonna round the answer to 3 decimal places, all right? Okay. The formula. So from the arc length, we just add 2 pi and the function, okay? Radius. Okay, so surface area, which is 2 pi, then the function in this case, let me write down function, then square root to arc length, 1 plus f prime over x, quantity squared, right? So f of x, square root of x between 1 and 4. Now, what's the f prime of x? F prime of x?
Minus 1 over 2.
Square root of x. Okay. Now, f prime of x squared, then we have 1 over 2 square root of x. What do you get this one?
1 over 4 s.
Excellent. All right, so we're gonna write down 2 pi from 1 to 4 f of so square root of x and 1 plus 1 over 4x, right? dx. Okay, now radical, in the radical we can multiply, we can divide, right? So we multiply, we can do that. So 2 pi from 1 to 4, we multiply with 1 will be x plus we multiply so square root of x times 1 over, we can do that 1 over the 2. What do you get this one?
1 over 4.
1 over 4? Okay, so this will be inside the 1 over 4.
Yeah, inside 1 over 4.
Okay, dx. Now, make a, we can just integrate by this one, right? How do we integrate? We had the experience.
Should we do a u sub again?
Okay,
U equals x plus 1 over 4.
excellent.
Du equals dx.
Excellent. So we have a 2 pi from 1 to 4 u to the 1/2 du. 2 pi, we had the experience already 1/2, which is 3 over 2, 2/3. And we do u to the 3 over 2 from 1 to 4. Now 4 pi over 3. And u was square root of x plus 1/4 from 1 to 4. Now 4 pi over 3. Now we have a 4 plus 1 over 4. Can you please calculate?
Oh, you I think we lost the x.
Oh, okay. Oh my God. What's
Oh
going
no.
on? Don't look at that. What's going on with me? Oh, so sorry. Oh my goodness.
It's okay.
I think that's my favorite power.
It's not the most pretty power, I feel like. The fractions are, I feel like the fractions get kind of messy.
Uh-huh. Oh, second time. All right. Okay. Now, can you please calculate Using decimals is better because in calculator you cannot see which one is a parentheses, which one not. And especially there's a fraction going on too.
I got 30.84649.
Wow, you guys so nice. So she confirmed. Okay, thank you very much. All right, so last one. So screenshot, last one. Okay, I'm doing that. Oops, machine. Okay, can you please read? In this case, it's revolving y-axis, y-axis, right? Y-axis, okay? Now, we're gonna write down everything in terms of y variable. So look, we have 3x to the 1/3. We're gonna solve 1/3. See? 1/2 is my favorite power. 1/3. Solve for x. Okay. Look, how do we solve? Since a cube root, we make a cube, right? So we have y cube equal to then we don't have the 3 there, so 3x, correct? Okay, now divide by 3 both sides, so x equal to y cube over 3. Yes? Okay, this is a better look. Okay, now we're gonna make this is as 0 over y. Can you derivative with respect to y?
Just y squared.
Y over 2, y to the second.
Very good.
That's y squared.
All right, then we make a square down. So y squared, which is y to the 4th power. So we're gonna use the formula, the surface area, which is from C to D. Oh, there is 0 to 2. Two pi. We have 0 over y and square root of 1 plus g prime of y into t squared. Okay, let me make a mute for everyone. So if you want to talk, please unmute for yourself. Okay, now 2 pi from 0 to 2, we had g over y, which is 1/3. Y to the 3rd power. 1/3, let me take out of the integral symbol. So 1/3 there. Y to the 3rd. Okay, now we done. So 1 plus g squared, which is y to the 4th power. Okay. How do we integrate we had experience earlier. You stop. Like u equal to 1 plus y to the fourth power. And what with derivative with respect to y, what do you get?
4y 3 power dy.
Okay, so look, we have a y to the third power dy, but not 4, right? So we divide by that. So we have 1 over 4 du, which is y to the third du. I'm sorry, dy. Okay, so we have a 2 pi over 3 and then 1 over 4 from 0 to 2. U to the 1/2 and that one is 1 over 4 du. Power we have experience. So pi over 6 and u to the 3 over 2 2/3 from 0 to 2. Pi over 9. So u was 1 plus y to the fourth power 3 over 2 from 0 to 2. Okay, your turn. Pi over 9. 1 plus y to the fourth power, which is 2 to the fourth power 3 over 2 minus 1 plus 0 3 over 2, which is 1. Can you please calculate? Approximation is good too. So let me help you a little bit.
I got 24.1178794.
Wow.
I got that too.
Oh, you got that too? Okay, good job. Thank you very much for participating. You guys did really quick, okay? Thank you for coming too.